Hello everyone. Have you ever seen a machine learning model showing 95% accuracy yet failing badly in real life applications? So many beginners think that higher accuracy automatically means a better model, but it's not always true. So in this session, I will explain why accuracy alone is not evaluate a classification model. So and how a confusion matrix helps understand model performance in a much deeper and meaningful way. So let's understand this using a simple example. So suppose we are building a spam detection system. So our model predicts either whether email could be not spam or it might be spam. Okay. So since this is a binary classification problem, so there are only two predicted classes. But when we compare these predictions with actual values, so there are four different outcomes are possible. Okay. To represent these outcomes, we use something called confusion matrix. Okay, so this is how our confusion matrix looks. Okay, so on the top right side, we write the actual positive and actual negative. And in the side, bottom side, we write the predicted positive and predicted negative. Okay, so now let's come to the terminology name true positive, false positives, false negative, and true negatives. So let's understand each terminology carefully. Okay, so now true positive. So actually, what is true positive? So when the email is actually spam, okay, and our model correctly predicts it as a spam, so this is called the true positive. This is a correct prediction. Okay, so this is a correct prediction. Now move towards the true negative. So what is true negative? So when the email is actually not spam, okay? So when the email is actually not spam and the model predicts not spam, then this is called true negative. Okay? So again, it is a correct prediction. Okay? So this is also a correct prediction. Okay? Okay. Now then move towards the false positive terminology. So what is false positive? False positive. So now suppose the email is actually not spam. Okay, I'm repeating again. Now suppose the email is actually not spam, but the model predicts it is a spam. Okay, so this is a false positive. This is a false positive. So the prediction is wrong. Got it? So the prediction is wrong. Now move towards the false negative. Okay, so now suppose the email is actually spam. Okay, the email is actually spam, but it but the model predicts it's not a spam. Okay, so then it is called false negative. So again, this is a false prediction. Is it clear? So from this matrix, we get four important values. Okay, which is true positive, true negative, false positive, and false negative. Okay, and using these four values, we calculate different evaluation matrices. So, what are these evaluation matrices? The number one is accuracy. Okay, so first let talk about the accuracy. So, accuracy is defined as the true positive plus true negative divided by total number of observations. Okay, all total four observations. Accuracy tells us the overall correctness of the model. Okay, so now let's check about the what are the problems arises from the accuracy. Let's suppose we have 100 emails. Out of them, 95 are normal emails. Okay, and the rest 5 are spam emails. Okay, now imagine our model predicts every email as not spam. Okay, what will be the accuracy? So the accuracy will become percent. Oh, sorry, 95%. Okay, but the model failed to detect even a single spam email. Okay, so even the accuracy is a 95%, the model is completely useless. Okay, so this is that is the reason why the accuracy alone is not reliable, especially in imbalanced data set. Okay, so our next matrices is precision. Okay, so what is precision? The precision is defined as the true positive. Okay, the true positive is divided by the true positive plus false positive. So what this formula means, actually what the precision means. So precision answers the question of about out of all the emails that the model predicted as spam. Okay, I repeat it again. Out of all the emails that the model predicted as spam, so how many were actual are spam? Okay, so this is the question that answer by the precision. Okay, so if precision is high, it means when the model says spam, so it is usually correct. Okay, now let's move towards the next evaluation matrix named recall. So recall is defined as the total positive, okay, total positive divided by total positive plus false negative. So what actually recall tells us? So recall answers the question like out of all the actual spam emails, how many did our model successfully detect? Means if recall is high, okay, if recall is high, it means the model is good at capturing positive predictions. Understand? Positive, or we can say that capturing positive cases. Okay, so now let's also clear off the one more. Okay, now FNS score. So what is FNS score? So now something we need a balance between precision and recall. Okay, so for that we use FNS score. Okay, so actually what is reference score? Let to reference score is 2 is multiplied by the precision into recall divided by precision plus recall. Okay, so F1 score is the harmonic mean of prediction and recall. Okay, so what is harmonic mean? Harmonic mean is like penalize extreme values. Okay, so F1 score becomes high only when both precision and recalls are reasonably high. Okay, when the both are high, then the F1 score become high. Okay, now let's consider a real world example. See why it is important in a real world scenario. Okay, so the first is our consider as a medical diagnosis. For example, cancer detection. Okay, so recall is extremely important. Okay, so recall is extremely important. Okay, because missing a cancer patient, which is a false negative, it can be life threatening. Am I right? Okay, so and let's consider it in a fraud detection. Okay, so what the cases can be seen. So again, recall is important, because missing fraudulent transaction can cause huge financial loss. Okay, so here the recall is important too, because we might face huge financial losses instead because of the missing fraudulent. Okay, now let's check in the spam filtering. So precision becomes important here. The precision plays a role. Precision is important. Okay, so because we do not want important emails going into the spam. Okay, so we do not want the real emails that we require will send to the spam. So that we don't want. Okay, we don't need. So depending on the problem, we choose the right evaluation matrices. Okay, so there are the different perspective of using these evaluation matrices. Okay, so today we learned that Confusion matrix is a powerful tool to evaluate classification models. And instead of relying only on accuracy, we should analyze precision, recall, F1 score. Okay, so truly understand model performance. Okay, from this we can truly understand the model's real performance. Okay, so this become especially important when dealing with imbalanced data sets. Okay, so we need these analysis. Okay, so thank you for listening, and I hope this session help you understand confusion matrices in a clear and a practical way. Okay, so that's from all from my side. Thank you.